Welcome, I'm Thomas with PCO America. PCO is developing scientific camera systems for a variety of applications since over 30 years. One of the main characteristics of a camera or camera system is the so-called dynamic range. You will find it in all of our data sheets. You probably have read about this in other camera manufacturers' publications. So, in the next few minutes, I will give you a quick introduction in what dynamic range in general is, what are we talking about. Then I want to make you aware of two different ways to look at dynamic range that you should know the difference between. And then we'll answer the questions, okay, why does it matter? Why is that fuss about dynamic range? Why should you bother? So what's the general principle here at all? So you have the photons and you collect photons in your sensor, in the camera. The photons create a charge carrier within each pixel. So this creates a voltage on the sensor in each pixel. And then you have to get this voltage out of the sensor and the camera at the stage where you implement an analog to digital converter. And what it actually does is it gives a representation of the light level that you collected into the digital world, into a real quantified number. So this analog to digital converter has a certain digitization, and this is usually by the power of the base of 2. And if we look here, and you have heard that, for example, if you have an 8-bit conversion, this means your converter will create 256 single steps. What that means is that whatever light you collected at the fullest, the brightest situation, you can distinguish 256 different shades of gray, if you want so. If you have a 10-bit converter, then this will provide you over 1,000 different steps, and so on, and down to 16-bit conversion, over 65,000. So what does it mean? So, like here in this booth as well, we have areas that are grayer, they're darker, others are very light. And between the very lightest light, so to say, and the darkest situation, this range, this is part of what we call an intra-scene dynamic range. And that's what we want to capture. And you have seen the difficulties with your personal camera, with your smartphone. Then if it's very bright outside and you're just looking at the window, you have to make a decision, right? Either you focus outside to get the very bright light, or you focus on the darker side to make that. But both is very, very difficult to capture. So let's come back now to our scientific cameras. So what you have seen here, the digital conversion, this is at the end of the process, so to say. But there's dynamic range also happens right on the sensor. And there the definition for the image sensor dynamic is given by the full well capacity by the total readout noise. So the full well capacity, there is a limitation of how many photons you can get into a single pixel. So this would be the higher end, that's the real bright side. On the other side, if you have no light at all, you will still see something from your camera, and that's what we call the noise. And there's all kinds of noise factors and then that contribute to the total noise. For now, let's just keep it simple and refer to the total readout noise of that sensor. And this will give you the dynamic range, what the sensor can do with the light you're putting on the sensor. Now, let's look at some specific numbers here. For example, take the Sony ICX285, a very popular sensor for decades now in the market. This sensor has a full bulk capacity of 18,000 electrons. Compare, for example, our BIE Fairchild sensor, a CMOS sensor, with 30,000 full bulk capacity. So what does it mean is, with our edge camera system, for example, you can capture much brighter light than it would be possible with a Sony sensor. Now, the different sensors have different readout noise, as you can see. And if you take this in the equation, then you get a different dynamic range. And you will see that on the scientific CMOS side, we're way farther away from what's possible with a typical CCD. And this is what we provided to you in the scientific CMOS cameras. That's in the PCO Edge camera series, as well as in our newer Panda series of scientific CMOS sensors. So now keep in mind, this is what the sensor can do. And what we as a camera manufacturer then do for you is we pair with this sensor the right analog to digital converter. So what we want to provide to you is that all the information that you have in this dynamic range is presented to you. And therefore it's important to know how you digitize. And sometimes, and this is what I want you to know, is sometimes you need to look carefully if the information that's provided to you does it talk about the analog to digital converter, or does it talk about the capability of the sensor? Both has to fit, sometimes it doesn't. So make sure that those fit together and you get all the information that's on the sensor. Now, what does it mean at all now? The benefit of a high dynamic range is information. So see, for us, our eyes are only capable of 8-bit, seeing 8-bit. The screen of this laptop, your screen at home at the TV, usually are 8-bit systems. So they cannot display more than 8-bit interscene dynamic, and that's fine because we cannot see more. Yeah, there are some people out there who can see 10 bits and they get different, in the scientific world, different screen for that, but for us, normal people, that's it. So, and for all your daily life imagings, that's totally fine. You don't need more than this. But we're talking about scientific cameras, and what we want to provide to you is a measuring tool, a tool where you not only can see, but also get all the information that's within the whole range of the dynamic. The answer really is more information. A higher interscene dynamic range corresponds to a larger amount of light levels, which can be detected and distinguished. So how can this happen? So have a look at those 4 columns here in this picture. The extracts in the 4 columns have been generated, and this is important, from the same 16-bit raw image taken with our PCO Edge 5.5 color CMOS camera. The original image was exposed in a way that the bright lights of this supermarket building here were just exposed in a way that they did not overexpose. Therefore, the full amount of information is present in the raw data, but it cannot be observed in this version, in this image, because we can clearly see what's bright here, and we can imagine that there's something back here. And it's important now to know the information is there. We just can see it in that way if we display it this way. So from the left to the right now, the conversion range is minimized, revealing from column to column more details, which is more information, in the darker areas of the image, until the right column, where the conversion ratio is down to the low light range, which in effect has it seems that these areas are now overexposed, but now we can see what has been in the dark in this image here. So keep in mind, these are not 4 different images taken at different exposure times. This is the one image taken at one point with 16-bit dynamic, and all the information is in that image contained. So now, in the scientific world, you might see something like this: fluorescence microscopy. And in former times, if you had areas with bright light and darker areas, you often had to do multiple exposures, multiple pictures, imaging, so that you capture everything that's happening. But then you don't have the time correlation anymore. So with a high dynamic range, like it provided by a scientific CMOS camera in 16-bit, you have all the information in one image. It's then just a matter to adjust the conversion, how you look at it, so that your eyes can actually see all the details that are hidden in the dark here. But all this will do your software program, your sophisticated analysis afterwards can take this one image and get all the fullness of information. So I hope that helped to give a little bit more light into this dynamic range topic. If you want to hear more and read more, please go to our website. At PCO, with all our cameras, we want to provide you with the maximum data possible in your image. And this is why we pair the right converters with the right sensors, and we make sure no information gets lost along the way. Thank you.